This video will explain orthographic projection of point in all projection systems. Projection of point will help us understand basics of orthographic projection of line, plane and solid. We will also see how the orthographic projections will change as we change the angle of projection systems, these first angle, second angle, third angle and fourth angle projection systems. Let us see the projection of a point in the first angle projection system. So this is a point, the point P, and this point P is in the first quadrant. It is 50 mm in front of the vertical plane and it is 40 mm above the horizontal plane. So this is the position of point P. Now the observer is looking from the right side to project point P on the vertical plane for front view. So the front view is projected on the vertical plane. For the top view, the observer is looking from the top such that the object is between the observer and the plane of projection. So the top view will be projected on the HP. So the top view is represented as P and the front view is represented as P prime. This distances of the front view and the top view can be seen. So the front view will be at 40 mm from the reference line. Because 40 mm is the distance, the point is above HP. And the top view will be 50 mm from the reference line XY. This is because the point is 50 mm in front of the VP. So now we have made the projections of point P on the VP and the HP, the front view and the top view. So the HP will be rotated in clockwise to make it on a 2D. So let's draw the projections by freehand. First is the reference line XY. Then we will draw a vertical line because both front view and the top view will fall on a single line. Single line which is perpendicular to the reference line XY. So this is the front view P prime and the top view will be below the reference line P as shown here. So the distances are shown as 40 mm for the front view and 50 mm for the top view. So this is first angle projection system. Now we can see how we can draw it on a drawing sheet. So again start with the reference line XY. Draw a line which is perpendicular to the reference line. The front view and the top view both will fall on this perpendicular line. So the front view is above the reference line. The top view is below the reference line. So this is the front view. And we can locate the top view, which will be 50 mm below the reference line. This is the front view. Now we can do the dimensioning. So this is the projection of point in first angle projection system. And here we can see that the top view is below the reference line and the front view is above the reference line. Now we will draw the orthographic projections of the point P in the second angle projection system. So the point P is in the second quadrant. And it is 50 mm behind the vertical plane and 40 mm above the horizontal plane. So the observer is looking from the right side and the plane of projection is now in between the object and the observer for the front view. For the top view, the object is in between the observer and the plane of projection. So the front view and the top view can be shown. The front view is on the VP and the top view is on the HP. So front view is 40 mm away from the reference line and top view is 50 mm away from the reference line. Now the horizontal plane will be rotated in clockwise direction such that the top view and the front view both will fall above the reference line when we are drawing the orthographic projection. So we can draw the orthographic projections in the second angle projection system. Reference line, we draw a vertical line and both the top view and the front view will be above the reference line. So the front view will be at 40 mm above the reference line and the top view will be 50 mm above the reference line as shown here. So this is the second angle projection system. So now we can draw it on a drawing sheet. So we draw the reference line and then a line which is normal to the reference line. Both the front view and the top view will fall above the reference line. This is the front view, P prime. And this is the top view, which is represented by P. Finally, we can do the dimensioning. So the front view is 40 mm above the reference line. The top view is 50 mm above the reference line. So this is second angle projection system. Now let us see how a point is projected in the third angle projection system. So now in this case the point is situated in the third quadrant. That means behind the VP and below the HP. So point P is 40 mm below HP and 50 mm behind VP. So now the observer is looking from the right side for the front view, and the plane of projection is in between the object and the observer. So the front view is made on the VP at this spot. For the top view, the observer is looking from the top. Plane of projection is in between the object and the observer. Again, this is the top view. So the front view is at 40 mm from the reference line, below the reference line, and the top view will be at a distance of 50 mm from the reference line. Now the horizontal plane will be rotated in clockwise directions such that the top view will go above the reference line when we make it into a 2D. The front view remains below the reference line. So let's see how we can draw it. So the reference line XY, and then a vertical line we draw, and on this vertical line we draw the top view and the front view of this point P. So P is the top view, which is above the reference line, 50 mm above the reference line, and P prime is the front view, 40 mm below the reference line. So this is the projection of point in third angle projection system. Let us draw this on a drawing sheet. So first we draw the reference line XY and a vertical line or a normal to the reference line, and on this line we will show the front view and the top view. So top view is above the reference line and front view is below the reference line as shown before. Finally, we can do the dimensioning. Always use thin lines for the dimension line. So in the third angle projection system, we can see that the top view will come above the reference line and the front view below the reference line. Now finally, the fourth angle projection system. So the point is in the fourth quadrant. Point P is 40 mm below the HP and 50 mm in front of the VP. For the front view, the observer is looking from the right side and the object is in between the plane of projection and the observer. So the front view is projected on the vertical plane and the front view will be 40 mm below the reference line. And for the top view, the observer will see the object from above such that the plane of projection is in between the observer and the object. So this will be the top view of point P. We can see that the top view is 50 mm away from the reference line. Now we will rotate the horizontal plane clockwise such that the top view P will come below the reference line when we draw on a drawing sheet. So let us see in a freehand sketch. So both the front view and the top view will be below the reference line XY. So this is the front view, P prime, and P is the top view. The front view is 40 mm below the reference line and the top view is 50 mm below the reference line. So this is the fourth angle projection system. So now let's see how we can draw it on a drawing sheet. So first the reference line and then we draw a line normal to the reference line. And both the front view and the top view will come below the reference line as shown here. So this is the front view and this is the top view. Finally, we can do the dimensioning of the front view and the top view. So this is the projection of point in fourth angle projection system. So in this video we have shown the projection of a single point in all the four angle projection systems: the first angle projection system, second angle, third angle, and the fourth angle projection system. Finally, we should note that we only use the first angle projection and the third angle projection system for any kind of engineering drawing.